Test 1, 2, 3. Right, audio seems good. Let's get started. Ladies and gentlemen, welcome to the Discourager of Hesitancy. We are working on text rendering. We did some okay things yesterday, but we seem to have gotten stuck on rectangular clipping. Which right now, our text is enclosed within a rectangle, which we define. And if we run out past the edge of the rectangle, we want the option to turn on clipping so that the X gets cut off at the edge of this rectangle. Boop, right there. Right now it doesn't do that. It just keeps drawing the X out. It doesn't onto this rectangle. So we came up with a little algorithm, and we were trying to play around with it yesterday, but I'm not an OpenGL master. I'm not a GLSL master. I don't know fragment shaders very well. So it's possible that I made some misunderstandings, I guess. And I hope we can get past those today. If we get through that, then word wrapping will be the next thing. But here we go. So here's one of my problems. I was looking at the GL frag chord. In this way. Okay, where width is the number of pixels in my, well, it gets complicated. Where width and height are the number of pixels in my viewport. Okay, that's where the rectangle is defined, in the viewport. The area we define on the screen to draw. Do people need to know what a viewport is? Okay. So we have a screen, and sometimes we want to draw just two parts of it, right? So maybe you have a 3D game, but you have a heads-up display on the bottom bar, or maybe your inventory is on the left panel, right? In which case, we'll define a viewport to be the bottom bar, and we'll draw only to that area, and it'll never spill over on top of other things, because it's bound to the pixels we set. So that's fine. But the frag coordinate, okay, so we have a viewport within our screen space. And that's all defined in pixels. But the GL frag coord that we're doing math against is not actually in these coordinates. It's in what's called screen space coordinates, and I don't know what the proper name for the pixel-based one is. But in frag coord is always defined in a normalized coordinate system, which means your width is 0 to 1, your height is 0 to 1, and that's it, no matter what the aspect ratio is. So we were doing math against pixels when we needed to do it in screen space. So I think that's where most of our problems right now are coming from in our shader not doing anything. So I think that's what we need to tackle first up today. Okay. So here where we compute the four corners of our rectangle, our text rectangle is going to be defined by 0, 0, rectangle width, rectangle height. We will apply the MVP transform to those four corners, and we'll get it in screen pixel space. Then apply screen and viewport to get screen space of four corners. I think that's the stage we need here. we do this in the vertex shader, it doesn't cost as much as in the fragment shader. Most of the time, our polygon, our triangles are much bigger than a fragment, so we get a lot of fragments per vertex. So we do all the math we can in the vertex shader, then we pass it to the fragment shader as just 4 corners. So I think that's the plan today. So it's shader stuff. I don't know shaders, so I am learning the hard way as usual. And if anybody has constructive suggestions, let me know. So one thing we can do is we can run a lot of the math we need for testing outside of the shaders. Since we're using GL math, the math is implemented to be the same on the CPU as on the GPU with GL math. So we should be able to take the MVP on the CPU and print values out and see that they make sense. And then we can fiddle around on the CPU getting the screen and viewport coordinates right. So we get screen space of 1 quad. So hopefully that makes sense. We're going to try to figure out these 2 steps on the CPU, then we'll implement it on the GPU. The fragment shader can do its own triangulation. That's pass screen normalized screen space corners to frag shader. 2 triangles from the 4 corners. Then we do the dot product testing. I think that's the plan. So this is screen space. I'm just going to put up a little definition so that when we come back to it later, it'll be here. Screen space is top left 0, 0, bottom right is width, height, and units are pixels. Normalized screen space. I don't know if these are like industry terms, like these are just what I'm using. So take it for what it's worth. Top left is always 0, 0. Bottom right will always be 1 and 1. Period. So when I talk about normalized screen space, I'm talking about these floating values. I'm talking about screen space, I'm talking about pixels. So hopefully that all makes sense. So off to the code. Where did I leave off here? I said in the vertex shader, get our width and a height, and make sure that neither of them are 0. We're passing in a rectangle that's all zeros, as by default if we're not clipping. So it's basically saying, if I'm not clipping, then we pass in all zeros on our 4 corners. Otherwise, we do math here. This math is one stage of what we need to do on the CPU to test. Okay? Then, these 4 corners are given to the fragment shader. And what we're going to do for now is we're just going to short circuit this. This drop points is not going to help us at all because it's outside of the we're never going to get a fragment in the areas we care about. Sine function test point in triangle. We'll test all this on the CPU, then re-implement here. Test point in. I have that in for like a debugging thing. Main. Are we inside? We're not going to do either test. We sample our texture. Okay, is inside. We're just going to hack something in real quick, just for testing. Is inside equals. Oh, just kidding. If VP naught x equal not equal to 0 or v underscore p 0 dot y. Let's just simplify this a little bit. Equals 0. So if the first point is not at the origin, and the first point, like if we get 2 points that are the same, then it's not a valid quad. We only send in zeros if clipping is not enabled. So so basically, if we don't have clipping on, it'll just always be true. We're not testing anything really. Then we set the color. So our 3 text boxes should be black, black, green, black. Green is our error color, or our testing color. Okay, so let's go embed those shader updates. Then we're gonna go to our Sandbox. There we go. Let's go to shader warehouse. Reload it. File. Debug. Okay. Doing debugging on a GPU is notoriously hard. You don't get useful information out of it ever, except the visual that you were trying to create in the first place. So if it fails anywhere along the way, you don't really get to see it, which is why. Oh, good heavens. Too many parentheses. Okay, so yeah, this one is green, which means we've turned clipping on, black for clipping not turned on. That's basically our test right now. But we want to get one of these quads of one of these letters, and we're going to take that quad and we're going to print out a whole bunch of math the first time it gets rendered. Just to test our theory. Why don't we do it on a click, actually? Mm. So, for example, the letter P is completely outside. Letter T is, well, letter G is completely inside. Well, let me think. If I click my mouse, we're going to pretend like the mouse is the fragment shader frag chord. And then we will test the quote unquote frag chord against this rectangle. I think that's what we want to do. Okay. So step one, sandbox scene. Void test frag chord math. Set line spacing. Here in on update. Let's do in this one here. If we can use right click. Hit mouse. What is it? Is mouse button pressed? Input mouse button. I think right. We'll just do a right click. If we have right clicked, then we can get the mouse position X and Y. Frag X. So X equals input Y equals input. Test frag chord. Okay, just getting warmed up. Test frag chord. Okay. Mouse at mouse X, mouse Y. Okay, so let's just make sure that that fires off. It gives us a position. Oh, Oh, the bots. Bots showed up before anybody else did. It's a sad day. Oh, all caps. Why? Why am I so consistent with that? Capital casing, all case, all upcase. Ridiculous nonsense. Not sure what's wrong with me. I guess in my mind I haven't decided if enumerations... Like, I use all uppercase for constants, which an enumerated value constant is a constant, so I should be more consistent with that. More of a style thing. What? I have a not bot. Thank you. So, Dre vested. Is that better? I don't know how to pronounce that username. Dre vested. It's good to not have a bot. Welcome, welcome. Okay, so if we right click here, we get a mouse coordinate. Over here, we get a mouse coordinate. Yes, okay. Good afternoon. Yes, indeed. Okay. Now the math parts. What we want to do is turn our mouse click into what would be a screen fragment coordinate in screen space. So first we have to, our Y's are inverted, so we'll do that at the end. And I don't want to fiddle with the viewport just now. So, call it double drag x equals mouse x divided by renderer frame width y. And we'll just take the negative of that, or no, it's more like this. Frame width minus mouse y over frame width, which is really just 1 minus mouse y over frame width. But this is more straightforward from the derivation for me, so we'll do it this way. Drag drag x, drag y. We're gonna try that. The D at the end is silent. Travestit. Okay, is there a meaning behind that one? That's an odd username. So way up here, it should be close to zeros. Oh, interesting. Down here should be close to ones. X, Y. Oh. Well, already we have some problems. Right height. Right height. Copy paste is dangerous. So near zeros. Okay, so is my mouse Y really not inverted? I thought it would be. I can do it this way. This is why we're debugging on the CPU, not GPU. To prove the process works on the CPU, then we'll know exactly what to do on the GPU. Those are close to 0, that's close to 1s. Good. Okay. We're gonna pretend like those are our fragment coordinates. Okay, text has a raw rectangle. And this is what we want to test against. Should only happen inside the render after the... Okay, so we're going to make this slightly more complicated than Sandbox scene. Let's see. Bool do frag test. Do frag test equals true. Render. If underscore do frag test. Okay. In the render, we have the most up-to-date MVP. So we should pass that along. I think it's a map 4. Which is probably in the base class of scene. GL map 4. Test frag coordinate map. Now we have the MVP, or we will. We should make this a const reference for fun and consistency with other things. Okay, we've got our text, we've got our rectangles. We have our simulated fragment coordinate. So we have our rectangle. We're going to compute the 4 corners of the rectangle, which are x0, let's do this in 0 equals r dot x. X1 equals y0. y, x1, 1, right, y. Nope, let's just do this left, top, right, top. Pretty sure I have right, bottom, and left bottom corners. Okay, so we've got 4 points for a rectangle. Four yields 4 points. Two, three, four. One, two. So r dot x, r dot y, r dot width, r dot height. 0, y 0. x1, y1, x2, y2, x3, y3. Okay, so that's the rectangle we want to play around with. I don't even care about the quads right now at this point because it's fragment shaders we care about. Wrong rectangle detected. Nobody should care about that except I'm debugging, so I get to do this. Put this back in protected. Oh, comma. Oh, warning unused parameter, that's fine because we will use it shortly. I just want to make sure that the rectangle is printing out more or less correctly. Right click anywhere. Get a rectangle. 0, 0, 9, 19, 93 is the size of this rectangle. Do I believe that? What if we right click this corner, right click this corner? 97, 590, whatever. Okay. It's all reasonable. Okay. There's not interesting math here, so let's shorten up the logging of it. We don't let ourselves into too much information. Now, for temporary point, just a moment. temp point dot x equals x0, temp point dot y equals y0, dot z equals 0, temp point dot w equals 1. I need to set these here. Actually, okay. For first point, we do this. I would say temp point equals temp point underscore MVP times that. Actually, this is not the right MVP. We don't have to pass this in. We can get it from local transform world transform. We want the world transform of that object. All right, I'm getting ahead of myself sometimes. That's drag. And that's fine. You don't need to pass that in. Let's drag word the path. Connect for MVP equals. This thing dot world transform. There we go.
Are you gonna be a chef with me? Should I be a chef?
Double screen space x0 equals temp point dot x and y. Zero for 1. 0 for 2, 1, 2, 3, 4. 0 for 3, 1, 2, 4. We're just going to do P0. Screen space x 0. Screen space y 0. Except that's going to still be in pixels. This is not screen space. This is, well, normalized screen space we'll get into, I guess. GLM. Yes, we need to expand our. Oh, we have GLM. Okay. So basically, we're going to walk through everything that the fragment, the vertex shader is going to do. And try to get normal answers out of this thing. So what we're saying is P0 is at 187x and negative 595. Then we move over the x to this one, 1106. Then down to negative 502. I actually want these to switch. I think we need to subtract the heights from somewhere. Those shouldn't be negative. So that's where we need to invert our y's. Do we I think that's what we do. We just negate the y, so we don't have to input anything. Because the transforms and the cameras take care of that, which is the MVP again. So if I right click near this corner, the mouse position is 184, which is close to 187, and 592, which is close to 590. This is still negative. Did I not say negative? All right, click near the other corner. We get 4, which is close. 688. Yep. These are making me a little sad. Why are these negative? Didn't I negate the y already? Um, C equals 0. W equals 1. We have to do that from time to time. I don't think any of our transforms right now touch those, but you never know. We That'll be probably fine. That's the. Well, no, because it's negative. When I make a texture, when I make a vertex buffer, I put a negative in front of all of them. That's when I make the vertex buffer coordinates. So
Do you like Temple of Doom 1?
camera. Oh, okay. I have to take into account the camera. We're not hiding the camera in here yet. That's part of the problem. This. So take our world transform times our camera transform, MVP times our world transform. So normal view projection. So this is our view and our projection matrix here, which we then multiply by our model transform. That might help. Some of this stuff now happens sort of automatically. I have to think about manually doing it whenever we're debugging. We're doing math. Okay, now we're right near here. Now we're getting interesting numbers. This X value makes no sense to me, nor this one. These Y values also mostly don't make any sense to me. X naught minus Y naught. Okay, let me think. This is going the right direction. In that it's low, then gets bigger. It starts low. So this is not right. R is my raw, unchanged rectangle. Yeah. I'd expect where I right click 0.0 to be very close to this number right here. And it is not. This a little bit. Text. Rectangle.x. Alright, let's see here. Oh. It says it's not at all close to where it should be. Within the height, can we just move to? Oh, I do not believe that at all. Oh. Okay. Alright. Yes, yes. Raw rectangle. So there are multiple layers of MVP being added in because of text box. Okay, extended. Okay, so rectangle is the raw text rectangle, which is fun. Okay. VP times template. So let's go to text now. Times local transform. Okay, but that's because MVB is being passed in from text edit. We're taking the text edit rectangle, passing that down to text. So it is. This is basically the same thing as a world transform. Except we don't have to do this when he multiplies this out. Okay. Dot text object. Values are nowhere near where I would expect them to be. Why not? How can it be drawing to the right place if this is what it would get? Don't understand. When I do text.cpp render, this is the camera transform times the text edit transform times this text's transform. Which is this. It's in scene before we start rendering. You know, let's simplify it. Let's just simplify everything. Current camera times projection view matrix times text. You know what? Let's make this even more explicit. Underscore test rect clip dot local transform times text point to local transform. That's mathematically the same thing as what we've been doing. Should be mathematically the same. Right click. Yeah. What is this? What is this garbage? This is nowhere near 0.096, which is where we clicked. I don't even see a mathematical relationship between these two. Viewport would account for these not being negated. I'm pretty sure viewport is upside down. Set viewport. Zero width height. Our projection, yeah, flips the height, the viewport height. So that's right. Where's this number coming from then? I really don't want to play games with a viewport. This is all working except when I multiply this point by the projection model view calculation near here. This is what we get. What? Where is that? Let's see. Let's go to Sandbox. So let's not take text. Let's get edit rectangle. I'll tell us exactly where on the screen that rectangle is. It's no permissions. Now I give you all the permissions. Probably working in 3 or 4 different mathematical spaces. So I have the world space I think of, which is. Oh, wait. Okay, interesting. Yeah, let's just do that. Okay. The edit rectangle is at 187, 595. So these are close to these values. Perfect. I apply all the transforms. This is what it comes up with for a screen coordinate. This becomes this instead of this coming, whatever the heck this is. Does this have to do with the viewport? Okay, so we have the camera projection. Model. The view is the position of the camera. This seems a little odd to me. I'm not sure why we have the same. Not sure that's correct at all. I'm just curious. Set a rectangle. Rectangle. 21 divided by E. That's fine, I think. It's close to that, so at least. What does this mean? This here is not the screen space coordinate of this corner. So what have I done wrong? Okay. I don't remember what the ortho arguments are in order. Set the viewport. Projection. I think it's near and far clipping planes. GLM ortho. Let's see what earlier what's there. GLM ortho. It's I would like to know why. Ortho left, right, bottom, top, near, far. Left, right, bottom, top. Ooh, it's that way. Left is 0, because we want to compress the whole screen. Right is 0 plus width. Left, right, top, and bottom. I think one piece of our problem is we need to do the viewport transformation. In what? I would expect again the issues to be on the y-axis, not the x-axis. I'm not sure what the x-axis is doing. This gives me screen normalized points. Well, viewport normalized points. Renderer viewport.
Yeah.
Okay. The issue is on the y-axis. I'd be a lot less upset. But the problem is on the x-axis. It doesn't make sense to me. What is this negative x? And these are also wrong. So we're not out of the woods yet. But what is this? Okay. Question. This number being the same as this number makes me suspicious. I type something in wrong. X0, Y0. It's the rectangle top left. Which should be 0, 0. Y1. X, Y, X, Y. X, Y. These numbers make no sense to me. These should be. They're not screen space, these are viewport space, really. But either way, they don't make any sense. Should draw within. Coordinate points. 2, 3.
Joe.
These numbers make no sense. Negative 0.8 is like a full screen width off to the left. 161 is, roughly a seventh of the way from the edge. So maybe that's okay. But where's the X getting? Maybe if you add this in, like this corner over here. Is a little more than half. The bottom corner of this one here is just around the 0.5 mark, middle of the screen. It's a little further right of left. I don't understand this. This is 3/4 of a screen off the screen to the
Really?
What are these 4 points doing? Puzzled. Like the Grinch. Puzzled till my puzzler is silver. But I know this rectangle here has to fit into screen space. Oh, wait. Well, no. Here's the edit objects rectangle. Inside that, we have a text rectangle. Inside that, right? So if we go to, we write out, here's the edited rectangle. Here's the coordinate of the upper left corner. Here's its width and its height. Within that is a text rectangle. Maybe here. But for logging purposes, this isn't even right. Text r equals. Text. Point to. This is the. It's not the raw rectangle. This is the partially transformed rectangle. So basically, have an offset of 10 corners from the parent rectangle. Yeah, 10 pixels here, short 18 pixels there, 18 pixels there. Perfect. This is exactly right. But somehow 187 plus 9 pixels, which is 196. 196 pixels from the right, from the left. I mean, what's 196 over, what is it, 1440 width? 0.136. It's not even like a weird 1 minus thing. Okay, that's the transform that we pass in to the renderer. All I want is to take this rectangle and convert it into screen space. It should not be so hard. That's what this whole transform is about. MVP times zero, zero. What's this MVP do to me? It's like I said, this is not a viewport. This is not a viewport type of issue, mathematically. This should be like almost 0.5. Almost 0.5. This should be like 0.14 or something. This should be a little over 0.58 or something. We're not doing any rotations. We're not doing any scale. So the MVP might actually be something we can analyze. Okay, so just take world transform. Let's just print this. Modulus half space. X sub 0. Let's do this by row. 2, 3, 4. 1, 4. TX 8. TX 12. One, 5, 9, 13. 2, 6, 10. Last but not least, 3, 6, 11, 15. Assertion failed. If it's a 4x4 matrix, that should be 16 elements. Good heavens. Maybe it's overloading column 0, row 0. Oh, useless. What? So should copy a snippet. Sort of. Log element. X 1, 2, 3, 4. Get it in row major form, which is we like to think about these problems. I look into it. And it blows up. Insertion failed. So 196, negative 604. That's the Y. Yeah, 604. 196. That transform looks fine. So four. Insertion failed. We just put that all away. It's literally just a translation matrix. There's nothing weird about it. Okay. Transformation matrix makes perfect sense to me. I mean, it seems reasonable anyways. Projection view. This is orthographic, so it shouldn't be too bad. This is literally what I pass to the renderer, and it gets everything out of the pixels I want. So why? Projection view. It's basically a Y flip flop. X with VP. View projection -1 It's odd places. .001 is not very informative. So I kind of just trust GLM to give me the orthographic projection crap. When I multiply a point 0.001 by this, see here. That's where this is coming from. Zero. This is coming here. this value, this value. This value is this value. Don't know where this one's coming from. This is a 0, 0. What to do? The best way to go about this. I've been taking for granted that the ortho just works, and it does because it draws to the screen in exactly the locations I want. So why can't I just apply that to an arbitrary point here? I get a vector at x, y. When I get the x, y out, right? This is the position. This is our xy coordinate in our vertex buffer. It knows to shove the first two elements into x, y, it knows to make it 0 and 1. So it knows how to build this position, given we give it two floats. UMVP times position. Position of a vertex node. These are the only two lines that we need for now. Check our position, give us our texture coordinate, and we're done. Okay, I have no idea why model view projection. Is a rectangle. The one that matters is R. This one. Top left, top right, bottom left. So when we render our text object, these are the coordinate system that MVP deals with. All of our text is relative to this rectangle. So here, left, top right, bottom left, bottom right. We invert all the y's. These are the numbers that get. So we start at 0, 0. Plus the glyph left. Then the glyph width, glyph top. And the glyph bottom. So these numbers are literally in the space of this rectangle. All the transforms applied to that character, VP times that quad position or depth position. Is this. So y is MVP times x0, y0. Why is that not in normal screen space? What is that negative x-axis doing? Low effort Z's. Yep. Oh, is that the aliens from the old Sesame Street? Do we have any OpenGL experts watching? Tell me why I'm being an idiot. Build and orthographic projection matrix. Homogeneous vector, the transform vector would be planes orthographic projection transform given by the following matrix. So we can look at that if anybody's interested. So if we go this over here, turn on the browser over here. So this is the orthographic projection matrix, which is easy. This is a scaling translation. Right minus left. Top minus bottom, far versus near. So those are x, y, z. That makes sense. So that's what an orthographic projection matrix looks like, and it's frankly dead simple. So we don't actually need to start this, but we do need to look at this. Oh, my view projection translates as 0. So this actually is useless because our camera doesn't move right now. So we can literally just take the ortho left, right. Literally do that. These things, these are floats, so I don't have to cast anything. We did flip the y-axis in our projection matrix. Let's just simplify things a little bit. 2 over right minus left. Two over right minus left. Right is our width in pixels. Right, pixels. The translation is kind of killing me though. Where's that translation coming from? Plus right over 2. Left, right. So right minus left. So our width, 1440 or something? Width, 1920. 1920 minus 0. 2 over that. Two over 1920. That does look correct. What are these translation words here? Right plus left over right minus left. So 1920 plus 0 over 1920 minus 0. It's 1. It's all negative. Okay, so this follows all the rules of a standard orthographic projection. I guess we can check this value as being the only other one of interest to us. Top minus bottom. Top minus bottom. 0 minus 1440. Minus 1440 because of this. Minus 1440. Minus 1440. Two over 1440 is, yeah. That's fine. Why is that not negative? If it is top minus bottom, bottom then top. Okay, so it's 0 minus negative 144. Then yes, that is positive. Okay. If the graphic matrix looks fine, like, which I'm not surprised, like it's working in the renderer. So why would I multiply this times 0, 0? I get this. It's late here in Sweden, so I'm going to bed now. You too. Have a good evening. Sleep well. See you tomorrow. Thanks for coming. Appreciate it. 0, 0, 0. Only my son hadn't broken my calculator. Online matrix multiply. Matrix A dimensions of 4 by 4. Go. Okay, this one is paste 0, 0. Maybe I should show what I'm doing here. Browser. There we go. We're checking our math. Okay. 0, 0. 0, 0, 0. So I'm going to just fill in this value. This is our model view projection matrix. Times our position, which is 0, 0, 0, and our W of 1. Calculate. That is not screen space or anything like screen space. That is indeed what my program is outputting. So I'm missing something. There's another step that happens after the multiply. What am I missing? Point times MVP not yielding screen space coordinate. I don't want to project screen to world. I don't want to unproject the center coordinate. I don't want to project world to screen coordinates with camera position. All right. Here's our perspective thing, which in our case is an orthographic. Here's our model. There's an identity matrix. You transform, you rotate your camera. Your view, you invert the model. Okay, whatever. Model view times model. we're not translating anything. We're not rotating anything. So our view is literally the identity. So it's just model. Or no, view. We're not doing anything with the camera. GLM project and position. Model view projection. Oh, this is working code. There you go. Oh, see, what the? Why is this so hard? This should not be so hard. This. World coordinate, screen coordinate. I guess the output. Well, I guess this guy knows what he's talking about, right? Right? Is that what we just assumed? Okay. Let's copy paste. Yes. Okay. So I've been using homogeneous coordinates for this, which I guess is but seriously. I got to select everything. Okay. Translate it into our world. Don't think. In this case, world. World 0 and 2. So this is really we'll make it a function. Let's make it a function. Alright. Sandbox scene. Void world to screen GLM 30 of GLM 3 position. And let's put that back in for now. MVP. That's it. GLM at 4 MVP. Put it in here. Sandbox scene. Oops. We'll basically copy this here. P with MVP. World should be pose. These are temporary values. Viewport. Okay, I'm gonna get viewport. That is renderer viewport dot w renderer viewport dot w renderer viewport h. This is our outputs. Okay, I'm gonna pause here for a short restroom break. Let's see how far we can get. Issues with this very method here, but we're just gonna see where we get to. GLM 3 of this mess, this mess, and this mess. World to screen position by way of data matrix. world to screen of GLM 3 x0 y0 0. One, two, 3.3. Then we log those. VP times vector. Is that not MVP times a position? Should be the same. Math is math. No. Yeah, of course. The model view projection matrix looks perfect. Viewport. I have one other issue with this, and that might be that I have to offset given the viewport, but I'm going to fight that right now. Right click. I click that 184, 592. My rectangle is at 190, whatever, 595. That's close enough. And it says, I guess this is in pixel space. I have to, I absolutely must. I guess that's technically right-ish. $196. Our Y is nowhere near that though. So the x coordinates now look right in pixel space. Y values do not look right. Yeah, they might be right. Okay, let's go to here. Don't I have to take into account the viewport X and Y? Viewport is always at 0, 0. Ignore that for now, and scale this. Renderer frame width bringing height. So that gives our normalized screen space. This click. The mouse is at this, which should be close to this 0.58, 0.63. What about over this corner? Click. This. So 0.1. And this, yeah, so there. Something wrong with his y coordinate computation. Actually, even though oh, no, never mind. So this is near the bottom right-hand corner. So this number and this number should be about the same. This number should be about the same. They are not. This number and this number should be about the same. Yes. So the x is correct. Let's see on the y. This should be close to this 5.8. This, well, this 5.8 should be 4.12. And this 0.632 should be 4.78. But that could be because our viewport is upside down. So if it's 1 minus, it could be 1 minus 4.78. Yeah. No. Yes. Yeah. Yeah. Oh, but that's it. We have to flip our y. But it was renderer viewport. Oh no, it's just one minus, right? No, not here. That's it. No, I don't like this. This feels more magic than I want. So up here, bottom right hand corner. Okay, so top. So this is left edge is close. Top edge 412, 419. That's fine. On the right edge, 585, 58. Okay. This thing, which is not correct. It's not just 1 minus. But it is close. And it's computing. It's gotta be because the y's are not negated. Wow, 3 bots today. Good turnout. Wouldn't mind so much if they just stick around and watch for, just leave it on for a minute or two. 412 477. Okay. So I think we're getting screen coordinates of these corners. Which should still work when we rotate. It's using transformation matrix. So in theory, our math don't use S0. S0 is used once, S3 is used once, S1 is used once, S3. We don't actually need S2 at all. No, I mean, we'll leave this in for now. This is fine. Whew. I still say that the viewport offset needs to be computed in somehow. Question: how does viewport X, Y factor in here? It has to. Your viewport is not always at 0, 0. So that'll be another thing we have to compute. If do we add or do we subtract the viewport? That's the main question. Add or subtract? Oh, and do we add or subtract viewport offset? If our viewport is +10, +10 inside the corner, then our point within add or subtract the viewport. To test, we can badly hack our screen camera the default screen camera does this. So if we add a noticeable amount of pixels to the X offset, everything should draw 200 pixels to the right of where you'd expect. Oh, interesting. It didn't move anything, did it? Okay. Let's do it somewhere else then. We actually set our viewport here.
Oh,
Set viewport 200, 0, renderer width, renderer width, renderer height. Shift everything over to try that. It doesn't need a semicolon there, correct? What is wrong with my screen camera? What is going on? Projection view matrix. Center view.
Using the tennis balls.
I think this is extraneous. We probably don't actually need this. But oh, that's not done. Well, that should be fine. It happens before the first frame. Set viewport empty, set viewport rectangular. And then the camera updated in the first frame. It doesn't have to update ever again. Oh, okay. Wow, we're ignoring it. We are ignoring X and Y. We're not setting it in the renderer at all. I don't think that matters. X, Y, width. Okay, I suspect that may be part of our problem. For testing purposes. Okay, so we set it to 0, 0, 0. As we load in float, these are. Oh. Well, connection passes in R.X, R.Y, R.W, R.Height. Yeah, if we've been ignoring viewport X, Y for this long, that's not good. Yeah. Okay, update viewport. Underscore viewport rect dot X. Viewport rect dot Y. Now this is ortho. Well, let's comment that up for now. So our left edge will be underscore viewport rectangle X. Right. Actually, let's use the labels left, right. Minus viewport right dot. It's bottom or top? This is top. Minus the see how badly we broke things. Putting X's and Y's back in. Hopefully things render where they should. Okay, didn't break anything there. Good. Update viewport. So that's all correct. Fine. So then with Sandbox, let's set our orthographic camera the right way with the offsets. And I know why we did this is the screen camera. Okay, some issues.
This child is tired and deserves for now.
Did anything shift 200 pixels? That doesn't look 200 pixels further.
And wait, can we have? I didn't do any of that. You. What did he guess?
So, why is my viewport X not being honored? I think it's not being honored. Okay. I got things sort of lined up. Sandbox scene. Do that. We turn off our viewport. Hmm. It's let's go 500. Heck. Big changes. I thought 200 pixels would be noticeable. Probably is. I think the viewport's being properly honored here. Oh. Well, things definitely shifted. Pixels, that maybe 500 pixels move. Text seems strangely text. Why is this button still showing up correctly? While these buttons all moved somewhere. Why are they not here? How is these rectangles are very strange. Okay, this is making me sad. So our mouse position isn't taking into account viewport. Mouse position doesn't take into account viewport. Honestly, I thought we had all the viewport issues worked out ages ago. So this is, we once had things rendering in 4 quads. 4 different viewports. But the back button is still sitting right. The bottom center. Okay, what is going on? What have I done? Nice, I would tight. Projection matrix. Left, right, bottom, top. Near clip, far clip. Hmm. From to screen. Who's looking at screen height versus viewport height? There are some objects that seem more affected by my layout. What I suspect is renderer frame or viewport dot x and I think this plus renderer viewport dot y. That's how that has to work out. But nothing is drawn relative to the viewport layout I would like. Okay. We clicked on the screen. $4.99, $5.99.
No.
I suppose that's possible. 0.26, 1/4 of the way over. 0.4 less than half. So six point four. Point 58. So only one of these x's is correct. And correct is a very loose term here. What is going on with this viewport? That's a question I want to know. Okay. When we add in the viewport, things get really weird. The mouse should not care at all about the viewport. So these coordinates screen space are correct. I believe that the RX probably is right. Y is clearly wrong. Oh, well, I probably have to subtract my view. Subtract what Y? Remember the X first one. Right. Mouse position. About a quarter and about 4. 1. 4, 7, 4, 7. Okay. So that fixes that. What happened to this X value? 0.25 is not like this. 0.585 is close enough to be fine. So what happened here? X sub 0. X sub 0. Yeah. It's not relative to the viewport. Is that part of my problem? Five hundred is probably right about here. We're truncating everything above this point. Yeah, about 500, 500. So everything above here is not in the viewport, so it's not being drawn. So that's fine. This button is laid out relative to screen space, but it should have shifted way off screen. And this rectangle is getting mouse events. So this is the I don't know what. Is the text element getting the text element is not taking into account viewport? Other than the fact that viewport truncates it. Like, problem 1. I need this number. Oh. It's not drawing because it's clipped. But we're still this rectangle still goes this far. But the viewport isn't drawing it. Okay. Okay. So I think we're okay. So if we're over, I don't know, about here. 1741. Yeah. Okay, okay. So although it's not rendering it, this rectangle is quote unquote exists out this far. But this is clipped by the viewport here and here. And this top text box is clipped here. So this is 500, 500 roughly. Yep. Okay, okay. Oh, good heavens. I thought I was in big trouble. This all looks fine. I understand what is happening. So this these points are correct and take into account the viewport. So that answers that question, which means we can go back to not doing weird viewport things. And we can remove these log statements. If they are being honored. Okay, so close. I think that was good progress. I did not realize we had not used the viewport XY when we're creating our projection matrix, so good job us. Now we run this, and we can click top left corner, bottom right corner, and 0.096 should be very close to that. 0.4142, close enough. 1124, which is 585, yep. And 477, sure. Okay, so these rectangular coordinates are now being transformed into screen space. Phew. Okay, so Sandbox. Now we need bool does try contain point, and all we need are vec2 pose 2 p0 vec2 p1 vec2 p2. Like how hacky some of this feels right now, but we're gonna hide it all inside of a vertex shader. Okay. Final piece. Got our 4 points, and this is actually in our text fragment shader. Basically this. This. Did we? Let's see, within color quad. Okay, so this goes away, becomes undefined. This. Just keep the naming cons. Oh, let's. Yeah, we'll call it pose. That's fine. Pose. Turn. One last piece. Does quad contain point vec2 of 0.3. which looks like fragment shader. Like this. Boolean. Are we inside? Test our point in try given is sure. If we're not inside, we have to test the other one. 2, 3, 0. Turn is inside. Okay, so that is basically what we want to test. So those are world translated points. Let's see here. The edit rectangle, the text rectangle. And the question is, does the text rectangle, this is after the second top, or, yes, still within this one. Push contains contained. What was it called? Does try contain point? Or does quad contain point? So this is GLMVec2 of a thing. 3, 4. This is frag X, frag Y, SSX0, SS Y0, 2, 2, 3, 3, 2. Okay, does the quad contain this point? Question mark? Yes. Or no. Okay. Vec2 has not been declared. That's fair. Test point in Let's try. Let's try contain point. You'll change root from GL world or GLSL world, or assignments are done strangely. Okay. Macro assign requires 6 arguments and only 3 given. That's true. Loops are wide. Why? Okay. X, Y. Getting closer to testing the whole thing end to end. Okay, so if we get our fragment coordinate out here, the answer is no. If we get our fragment coordinate here, it still is no. Well, shoot. And yet, if we check the... So here's where we clicked inside. Screen coordinate. Oh, no, this might be fine. Click a little further in, because there's a 9 pixel buffer between this gray box and where the text actually goes. It's about 220. Yes, it is. So this algorithm. No. And we lost the box somewhere. Yes. Okay, so this algorithm may work in our shader. Is it time to port it all? Oh gosh. We're also crashing when we leave this scene, which makes me a little bit sad. You can at least see what that's about. Back. Breakpoint. Modified. Pass request size. Backtrace. Scene manager cleanup. Sandbox. Line 41. Kind of doesn't help. Freeing the sandbox is a problem. Oh, okay, well, it's entirely possible that a clean and build debug might fix the issue because GCC, or at least GCC in BMW world. So is that all the math we want to do? Do what we can in the fragment shader. There's less calls to fragment shaders than there is to vertex shaders. pass a boolean to OpenGL. OpenGL boolean uniform. I can send an integer. Or a descendant. Okay. Run. Yeah, that was no problem. Okay. So that's no problem. Yeah. We need this. Um, a world to screen. Okay. So in text vertex shader, we should do a uniform int u clipping enable. Thing number one. That's CTP. Actually, I'm going to set one I. If it's enabled, otherwise, don't think we need to send the clipping rectangle in this case. So, in other words, if u clipping rectangle clipping enabled not equal to 0, then we do all this. Oops. A bunch of stuff which is wrong. Otherwise, fragment shader in back no in int v underscore being enabled cookie enabled equals u. Because we're just passing it straight through. V underscore is flipping enabled. Flipping enabled. Inside equals false. Okay. So that's thing number one. Let's reduce reliance on special data patterns. This is the biggest problem. So we need a function void world to screen given vec 3 pose and a mat for MVP. These are in, out, back, screen space position. Steal that out of our sandbox. To screen. Okay. Pose MVP. None of that should be a problem. Float S4. S0. S1. S2. S3. We do not need S2 because we're in 2D world. We'll compute it as though we were not in 2D world. Okay. It's 3, it's 1, it's 3, it's 2, it's 3. Okay. We do need another quad for viewport and screen size. Oh my gosh. We have to pass in quite a lot of information to get text to render a clipped rectangle. It's been like a 2-day journey here. So we need to pass in yet more data. So clipping enabled, clipping rectangle, uniform vec for u underscore viewport, and a vec to screen size. Okay. Renderer with viewport, 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 viewport. Let's shorten these down. Float ux viewport.x. No. Y width height. 2 and 2. So view width. View width. View x. View height. Height. View y. Screen width equals view underscore screen size. So 0 screen height. Width. Screen height. Okay, how is this coming? This is not a return either. This is screen space pose x equals distance screen space pose dot y equals that s screen space pose dot z equals that. Return. Okay, lastly, pose sub 0 will become pose dot x. Pose sub 1 will be pose dot y. These are both valid representations. Pose sub 2, but I think that x, y, z make this a little more readable. So I want to steal the link. Where did my roll the screen thing go? So we have world to screen. In theory, world to screen of vec3 x minus y 0 with u p into v not make these 3 text fragment. These all have to be 3s now. Guess we ever want to use those that way. You have to set viewport and screen size. Makes me a little sad. Set a lot of uniforms. We probably might need to change our uniform handling later. Some other day. World to screen of W. Y plus H. What does that look like in our sandbox? So we get our 0 and 3, just the way I think. Then we need to negate y1 is y2 is bottom, which is y plus height. Yeah. This is correct. There are my 3 world points now. In theory, clipping enabled 2 things. Oh gosh. Okay, let's do a quick check on shader toy. Paste. This is a vertex shader. Hope it just works. Finally, it's thinking. Take a minute sometimes. So what I'm doing is I'm looking at shader toy, not shader toy, shader playground, which lets me run my script through something and get some very useful output before I embed it and rebuild my project. But it's taking a minute. Let's reload. Oh, now of course it gives input. Ugh, love it when web pages become unresponsive. My favorite. Oh no. My internet died again? I don't think so. Nope, looks fine. So what's wrong with shader ref? Shader play. Okay. Assuming that all works. We're ignoring all that code because it's just gone. If clipping enabled, we are quote unquote not inside area. Yeah, it's just. Oh, page file loaded. Text. Shader. Paste. Okay, this is GLSL. GLS lane. This is a vertex shader. Target OpenGL. And hopefully go. Okay. OpenGL. Nope, I don't care about as long as I get my error messages. We'll see who tests it first. We want to re-embed our shaders. There we go. That's shaders. Shader warehouse. File. Reload it. File it. Here's where we find out. We broke it. We did indeed break it. Undefined variable v, clipping enabled. Okay, I think I know what that's about. Rebuild shader. Shader warehouse. File. Run it. Okay, fragment shader. Implicit cast from int to bool. Fragment shader. It does not like implicit casting, which I'm actually sort of a big fan of, except integer types. That seems to be like a good place to have some implicit type. Okay, I'm getting closer. Shader. Line 30. Let me find it. Okay. Okay, well, text. Put it in. So we get something useful out of here. Okay. Text stuff. So clipping enabled, clipping rectangle. Text underscore text. Shader set for F. And a 2F, I think. Do I have a 2F option? Set 2F? Nope, 4F. We will add one. Easy enough. Shader set for F. Set 2F. Value 1, value 2. Build uniform 2F. Text shader. We need viewport. We set that to render. Viewport. Error import error import width. Okay, there we go. Two more. Screen size. Width and height. Screen width. Screen width. Okay, see how that goes. Oh, yeah. Okay, and it just outright crashes. Oh, well, we need to. So full clean debug just to say we did. Should just see the green text for the one thing. So we have not yet hooked up the triangles test. That's okay. We just want to make sure it sort of works. Get this done today. Clipping. Who knew clipping was such a hard problem? Jeez. To be fair, I know almost nothing about OpenGL, so there's probably an easy way to do it, but I'm also limiting myself to OpenGL 3.3, so it might not have been doing that for basically to reduce the size of things I have to learn this project. I also think it maximizes see, this error code tells me nothing. That's not a useful error code. OpenGL error code. Why is everybody complaining about Minecraft OpenGL error 1282? Invalid value, invalid operation. Glue error string. I guess I can try that view. OpenGL helper. Helper. If that's gonna work at all. I have my doubts. Oh, maybe it will work. No. No glue error string. GLEW error string. GLEW and error string. Glue get error string. I guess that makes sense. Probably. Now maybe we get a useful error out of it. Unknown error. That's not exactly helpful, is it? It probably has to do with setting next time. Do I have to set all of these uniforms even if I'm never going to use them in the calculation? Probably a dangerous question to ask, but so if we set them all, regardless which way we enter, it still blows up. Unknown error, not helpful. I would like a stack trace right there when it blows up. I'll bet it's in text. It has to be in text, right? You'll use a program called it's shade, right? Line 30. It's when we bind it. Text shader bind. Okay. I'm not getting any file errors out. Like I'm not getting any warnings from OpenGL. So next stop, text, fragment GLSL, we copy everything. Put that in the shader thing. Vertex shader. Run it. See if there's useful output there. Maybe there's an error. Text vertex shader. No. Wait a second, which one did I pick? Oh, no, this is the fragment shader. I'm testing the fragment shader. Okay. GL frag chord. Line 11. This right here. Oh, it's not. It is there. So it's complaining about this one. Oh. Why? Let's try that. GL frag coord is GLSL flat qualifier GLSL. Using a flat keyword, no interpolation is done. Fragment generated during the restoration. Imperative will get the same data. Okay, so flat. Very flat. Yeah. Okay. Let's rebuild. Let's see. I guess we could show this on. This is the most exciting. But it is a thing. We're just waiting for this to regenerate some useful output. What is taking so long? What is taking so long? We're taking this long before. Slow internet day. Oh, okay, so that worked. So this should work. Okay, text vertex shader. Just drop this bad boy in here. Where's my mouse? Thank you, mouse. Oh my goodness. For some reason, Twitch grabs my mouse. Four bots. Come on, people. Get alive. Vert. We'll try to compile this as a vertex shader. And hopefully get something useful out of it. Like, yeah, you did it right. That would be nice. So, looking at the fragment shader. It knows how to truncate effect 3 down to effect 2. I don't know, it may not. So maybe we need to do this. Back 2 to the 3. inside test point in try test point in. That's not gonna work anyways. Basically gonna be this. Oh, we have used one. Okay, cool. I am still making these changes to the fragment shader though, so it's fine. Zero. One. Two and three. Contains. These are back to 2, back to 2, back to 2, back to 0 to x, y. X, y. Vector. 3 dot x, y is inside. Oh, no.
I know, but I gotta give you that. I know you hate it. But you're
Right, we're short circuiting all that logic anyways. So let's run this through the fragment shader. Computer, give me back the mouse. Back to the shader. Paste that in. Just put the bottom. That's fine, that's fine, that's fine. Alright. 4, 6 inside. Okay. I think that all looks okay from as far as I can tell.
it's the bomb.
Then maybe we'll try running it from if this passes. GL frag cord. Why? What? Entry stage requires one entry point. This, I have declared this. I have said here is a vet4 GL frag cord. Instead of in vet4 this thing. So why? That's exactly. Exactly, copy paste from the website. I know it's reserved.
Hey, I wrote Harry what? So Audrey needs, she's moving her good dollhouse down to the basement and she's moving the living room.
Why would you think about GL frag code? I'm clearing it as input. I know it's reserved. It's the bizarrest error message. I don't know how much of this is. I don't know OpenGL versus. Okay, I think it's lying to me. Maybe it doesn't like white space I put in. You texture, you color. Those came in off the uniforms. That's fine. This isn't even useful error message. I know jailfrag word is reserved. This is how you declare it. Isn't necessary to declare the input variable. It isn't necessary. Okay, we can take it out. That's the thing we can do. Okay, Twitch, Adobe, stop fighting. Twitch and OBS AP. Let's just comment out the frag port then.
That's not my fault.
What? See, this is one of the things where you know that this was never written to be user friendly at all, ever. At all. This compiler is not useful. It doesn't teach you how to use the thing. And neither does any of the documentation. Okay, here's the fun part. It's now saying this doesn't need the flat word, I think. Line 9. This is line 9. Did it not tell me I had to put flat in? I could swear that's what that said. This is annoying. Oh. Okay. This is a fragment shader. Oh my gosh. Okay. Flat back in. We're comparing this one again. That's what I was complaining about. It was saying frag coordinate is reserved for fragment shaders, and it thought this was a vertex shader, because that's what I told it, unfortunately. Oh, jeez. See, it's not useful error messages. If it had said something like GL frag port cannot be declared inside of a vertex shader, I would have been like, oh yeah, there's a fragment shader. I'm not impressed, I'm afraid. Oops. Contains. Sign no matching overloaded function. Okay. And Twitch OBS. I've lost my mouse again. Twitch window. Here, then here. Two. Twitch. Of the modern computers, they so frustrating. Okay. So we're dealing with all vector 2's here, vector 2's here, vector 2's here. It's literally we just pass it in here. 2, 2, 2, 2, 2. Yep. Okay. Does OpenGL short circuit Boolean logic? Let's see here. GL SL short Boolean over. Oh,
Okay there?
That's it, lost name.
What, buddy? I'm gonna go on. You need fresh unders or you good?
Does GLSL Boolean logical or short mutation? It's not that I don't know. Okay, so that compiled. I think we're good to run it then. So let's hide the Brave. Oh my goodness. If Twitch Stop stealing the mouse. There. Now it should not fight over the mouse anymore. Okay, we're going to embed shaders. Then we will warehouse. Oh. Okay. Run it. And it blows up. Insertion failed, unknown error, not helpful. Okay. Shader, view, texture. Okay. Sandbox. Set clipping enabled. Let's not set clipping enabled. Let's see if anything works then. Maybe there's some logic wrong. It blows up. How much do I have to remove before it starts working again? Embed my shaders. Warehouse, reload, build. It still blows up. No useful errors. Nothing helpful. Oh man. Unknown error. This is even before we texture MVP color. I'm becoming very frustrated with GL vertex shader. I declare you know what? We don't have to do it this way. We can do things slightly differently. You don't have to out that at all. Just have this as a unit, the same form. There. Okay, it's my vertex shader. Is there a case S3 is 0? Is it blowing up on a divide by 0? So any screen position that would be 0 would make S3 0, and here we divide by S3. Here. But that's not even, that's, the computation is being started at the point we're getting errors. Enabled, yep, goes away, okay. Valid output, nothing looks too weird here. So I think our vertex shader is okay. So paste and fragment. Playground being this slow yesterday. Okay, it generates output as well. And my shaders. Full clean. I don't know why that shader will not bind. We're doing far less crazy stuff than we have recently. Actually starting to get under control mathematically. I think. find variable. Oh, I thought I'd take that out. At least that was useful output. Just more than we've gotten out of this thing for a while. Unknown error. Ridiculous nonsense. It drew things! Okay, that's part one. Part two, go back and do Sandbox. We re-enable clipping on the one, so that should make all the text green for the third text box down, which overspills itself on purpose, vertically and horizontally. So it's all green to tell us that clipping is on. Then we need to set all the data that we'll be needing. 1, 2, text vertex. Oops, that's not how that works. Okay, we're just making sure that that doesn't blow anything up. So do a reload. So the fragment shader will execute that code, but the vertex shader will execute that code, but the fragment shader will still do the same thing it's always done and just pick 3. Okay, didn't die, good. Right, text fragment shader. This, in theory, is the moment of truth. If all goes well, it should be green outside the box, black inside the box. Come on, come on. It's all green. It's all outside the box. Dang it. Well, well. Shoot. The vertex shader is computing a bunch of stuff. And I have no way to know what this is outputting. I think it's correct. That's not much of a guarantee, is it? Okay. There's no way for me to see at all. What is going on? Is that not saved last time? Maybe I just didn't have the file saved correctly. We can verify. X fragment shader. Uh, oh, text fragment shader. There we go. Point in try. Yep, so that looks correct. X, Y, X, Y, X, Y. This is the side. Yeah, there's nothing black inside the rectangle or green outside the rectangle. It's just all outside the rectangle. But on the CPU, the same exact math. If we click outside the box, we see that the mouse position is here, which we can pretend is the fragment coordinate here. And does it fit inside this rectangle, which starts at 102, so this is already less than this, so that's not in. That should be reasonable. The y coordinate would have been in, it's probably the middle of the line, so let's check over here. This one should be yes, and it is. So y is why is this text all green? This should be green, this should be black inside this area here. All that work, tested on the CPU, the full process. Not impressed. What's going on? Oh. Maybe something we can reasonably push. Top. There we go. That's it. Right. It's the exact same math. World to screen. world to screen. If clipping enabled is not equal to 0, I don't know. I'm flummoxed. I am flustered, bewildered, confused. Right. Time for a short restroom break. Okay. I don't know what to try next. This whole algorithm works outside the shaders. Does not work inside the shader. Which tells me what? Got no errors, no warnings. It compiles just fine in the shader playground. There's literally no info on where those letters would start turning black and containing like are these letters green? Should be black right here, inside this rectangle. I did this math on the CPU, and it's turning the screen space position, given the world position, and a model view projection matrix. Same math. Right is x plus y. Is x plus y. Y height. Where that flip happens shouldn't matter. Same exact logic. Flipping is enabled. I need these three. Flipping enabled. Set this. Set in the flipping rectangle, viewport, and the screen size. Viewport screen size. 442. Otherwise, we just set it to 0. Nothing else. It would say go. We get our texture coordinate from our fragment shader. Get a fragment coordinate built in. Get the uniform texture, the uniform color, and the uniform is clipping enabled. If is clipping enabled, test it. Okay. Let's try an alternative. We know that we're not doing rotations. So maybe we can say contains equals P naught dot x is less than or equal to P dot x. P dot x is less than or equal to P naught dot x plus P naught dot width. No. That's P1 dot M2 dot x. There we go. And so P0 is the top left corner. So P dot y and P dot y is less than or equal to P dot P2 dot y. This P2 is the lower right hand corner. Simplify it until we get something useful. Yeah, these pixels are not different. Okay. Let's do this even. Let's cheat. Let's cheat like mad. Contains equals P dot x greater than 0.525. So what I mean by that, it's any point on the screen has to be quarters marked. Should draw. Oh, well that's not 0.25. So is my frag chord. Curiouser and curiouser. Like here's half mark right here. So here's a quarter right here. Boop, and yet all these letters are black. Oh. Uniform does not exist. What? Clipping is enabled. Okay, well. Complaining about? New clipping rect does not exist. What's going on? Correct. Viewport screen size. Uniform does not exist. Beg to differ, they're right there. View clipping bracket. Viewport screen size. Well, suppose we can try zero filling a bunch of stuff. I don't think that is the issue. Maybe it is. I don't want to make too many assumptions about what OpenGL is trying to do here. Uniform does not exist. I beg to differ. Uniform location cache. Get uniform location. What's it doing? do not exist. Good morning. Is there audio? Oh, yeah, sorry. Maybe I'm a little far from the microphone. Oh, how's it going, Ingrid Gecko? I'm gonna need a compiler's day after today. Sheesh. OpenGL is frustrating me. Yeah, depending on how turnout goes for this Friday's compiler day, I may do more compiler days. I got good turnout last Friday, so that might be the way to boost my numbers. Might be busy full day tomorrow, though. Yeah, that happens. You can't plan your life around compiler day. I just really want this to kind of work a little bit. Full clean, full build, all new shaders embedded, and it's complaining about uniforms not existing. Que el diablo, ¿por qué? ¿Por qué? Okay. They're right there. You clipping right. Right there. Happening one. Oh, let's see here. Good question. Here that's P. Taken from location does not exist. What if I do it this way, right? Else. Shit. It's gonna spam output. Arguably, compiler is more fun when they run writing. Yes. Yes. I agree. But I also like getting ideas from other people's adventures. Yeah, it's just gonna spam it out there. Great. Uniforms. Why? Okay, OpenGL uniform location not found. Valid uniform in shader. It let's see here. GLSL common mistakes. Let's share the browser. Look at all the GL uniform functions. There's a parameter called uniform vec light position in your C++ code. Set it to 4. Should be 1 because you're sending one vec 4. Okay. GL uniform doesn't work. You probably did not bind to the correct shader first. Use program. That. Red 5 to the get uniform location, get active uniform. Returns -1. If there's a uniform that you are not using, the driver will optimize your uniform out. Drivers are really good at optimizing code. So it's removing it because there's one branch that doesn't use it. I think that's it. Good gravy. All right. So the short answer is text vertex shader. We can't do the these are all zeros. It's gonna be math. Okay. Let's do that. Text. How it can tell that that's it can't know. Is it optimizing them away because of this? The other thing we want to put back in is store the location and only report the error ones. So let's embed the shaders. Warehouse. It optimizes away code that I did not want to optimize away. I think that's what's going on here. No, it still says it does not exist. Text B. Those are commented out. It should always compute these values. Flipping rectangle. Okay, so that's not the answer. No, because one branch doesn't use it. Well, branches in shaders are weird anyways, because technically it compiles both branches. So you don't actually often save work doing that, but uniform, you're not using the driver will optimize your uniform. Now drivers are really good at optimizing code. If you're using your uniform, but none of the values computed from that uniform contribute to any output from the shader, directly or indirectly, the uniform will usually be optimized out. Typically, this is not a problem, since if you pass -1, instead of a valid, there will quietly do nothing exactly, but you also get -1 if you misspell the variable name. So that's awkward. It is legal to have the same uniform defined in different shader stages. When you call get location, it will return one location. When you update the uniform with a call to OpenGL uniform, the driver takes care of setting the value for each stage. Contains all the shader stages at once. Programs do not consider uniforms in a vertex shader to be different from uniforms in a fragment shader. Okay, good. Good. However, that does not change the fact that this is making me sad. Okay, let's do this. Let's say back to temp. B underscore P dot equals temp. Maybe we just can't pass in the output variables. BP1 equals temp. I'm just guessing at this point. Temp equals temp. Okay. Now, do I have to pass in viewport and screen size? Although clipping rectangles make you, so your guess is as good as mine. Maybe better guess. Screen better shader warehouse reload file. I'm sure it's something simple that OpenGL does that I just don't know about yet. Okay. Oh, implicit cast. Okay. We can fix this. Oh, interesting, actually. Text. Vertex shader. This is not a vec 2, this is a vec 3. We want these to be vec 2. XY. XY. .xy. Let's try that. Get text fragment shader 2. The only one we get that should not quite be right now is that one. Everything else should be back 2s. With shaders, shader, warehouse, file. Now, it may still be that we have the if in the fragment shader still killing us. Okay. So, next fragment shader. Here, it will always test if the point is in the pod. If is inside, you clipping enabled and is inside. Now there's no, like, I have to choose the color based on this. So like I have to have a branch somewhere. Can't just not have a branch. I'm just perplexed. Blows up. It doesn't cast from int to bool. Okay, that's fair. I did know that was thing. Equal, not equal, greater than 0. And is inside. Okay, that's yeah, backwards of what I wanted, but that's still wrong. Okay. Fragment shader is less than 0 or inside. That's what I meant. No, it doesn't exist. It doesn't exist. Why doesn't it exist? You know what? You know what? Fine. No. No. I don't know what's going on. I don't understand. It, oh dear. I think it's lying to me. I think this is not at all the error. I don't know. I don't get it. I am very sad. Where are the errors and the options to look at things? Why are they so useless? Okay, let's do this then. Simplify everything away.
Hey, you are in stop talking at home.
if you underscore, let's see, if let's just do this. If GL frag shape coordinate dot x is greater than 0.25. We'll do this one. Else, we'll do this one. That's it. Our whole fragment shader is just going to put. Oh, I guess we have to sample. If then. I don't know. Where is it declared? All right, we need to do that. Let's just. No, that's not what I wanted. Let's just run this. Yeah, so clipping enable disappeared because it never is used in. Okay. At this point, it might be removing things because we're not using it. Because clipping enabled is probably being. Well, let's put it back in. Okay, so there are two places where we declare the uniform. One here in the vertex shader. We say we need the model view projection matrix. We need an integer to tell us if we're doing clipping or not, which we're no longer using. What's our clipping rectangle, viewport, and screen size for doing that clipping within? That math all shows up in the world to screen function. And we need to pass those in. Let's say in vec for viewport in vec 2 screen size. Main MVP, and then we need viewport use screen size. I suspect that at this point, a lot of this is getting optimized out anyways. MVP viewport screen size. F. Are we inside the rectangle or outside the rectangle? Clipping enabled. It's greater than 0. We don't want in, we just want out. if is inside edit shader reload. No. Oh. Okay. So it doesn't complain about uniforms, but this green is not within the rectangle, which is what we want to test against. So, fragment shader. Is inside if p of x is greater than or equal to 0.25, 0. Contains equals false equals true. Okay, what is my fragment? What is my fragment coordinate dot x equal to? 0.25 is like right here. Is it giving to me in pixel space? I don't know what the GPU is even handing me. I'm told it is shader screen space. PL flag coord in pixels or normalized. Converting pixel location to normalized. Wait, what? Is that the problem? Is that my problem? Is that all this time that when somebody said it was in screen space and gave the example of 0 to 1, is because of their specific example where they had things normalized? If that is the case, uniform back to U screen size divided by U screen size. I read somewhere. It was 0 to 1. Somebody must have been using a wrapper. If this fixes it. What was this? Okay. So there, at least things are black and green. So at least, I mean, this is 0.5. What did I put in there? If it's greater than 0.5. Okay. But none of the other contains values work. Okay. Therefore, if inside of a rectangle, true. So we have 3 cases. We're going to try again. Cheers. Well, run it. Okay. The only one that's working is fragment shader x value greater than 0. So here's one more test. Let's do one more test. Then I gotta call it. E dot y. So possibilities are I do not need to normalize my screen coordinate, which would be nice. But I need to figure out what I'm actually calculating that is different. So let's see here. Let's just try that. Warehouse. Right. Yeah, so this green stuff after is green. We should flip that logic. E dot y is greater than.
Your feet. Oh, and sit down.
Oh. Interesting.
The Indian style chair.
So the fragment coordinate is flipped because my viewport is flipped. It should be screen space. So if I literally flip this, everything above the line will be. Wait. True means black. True means black. So we were like this, greater than 0.5. Why was the lower half green? So this would be the upper half green, which is the exact opposite of what I would expect. Except that I am flipping. I'm flipping the. Yeah. So if it's less than 0.5. So this is the opposite I would expect. So this actually behaves, this fragment coordinate now behaves almost exactly like the screen space I'm using. Oh no, 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 this is GL screen space. So Y starts at the bottom left hand. Okay, no, I'm getting my spaces confused. Y goes from 0 up. So if it's less than 0.5, it's back. Okay. We might know enough to be able to fix this the rest of the way. Alright, let's try. I don't remember. GLSL supports block comments. GLSL block comment. Okay. P dot x is greater than or equal to P0 dot x. Contains equals true. That doesn't look like that changed my thing at all. Next, fragment shader, if x is greater than one of the points of x, it's true. So maybe I can fully embed and build that. Bed, warehouse, reload, dump file. So nothing is black, which means if I flip this logic, all of it should be green. That's my theory. Let's make this more efficient. Big dash K run slash source builds debug sleuth.exe. Oh, nope, nope, nope. That's inefficient. We'll fix it next time. Oh, it should not have done it clean, at least. Yeah, okay. Okay, everything is green. So that one is true. Therefore, the inverse logic, which we can check. is if it is p2.x. If it's less than p2.x, that's a bad sign. If it's greater than p2.x, that's very strange. This should not be less than my top left corner. Oh wait. So this was so greater than here gives me black. Greater than is black. Less than is green. Okay. Just so we map out what coordinates we're getting and where we think we're getting them. Hopping off. Good luck. Thank you. I should hop off too, but now I'm just annoyed. Thanks for dropping in. Catch you tomorrow for the compiler day. Slash source take debug c dot slash semicolon run it. Okay, should be much more efficient. Success. It did not run it. We did end up where I wanted to. Source build. Builds debug world sleuth. Okay, that's the last thing. So those are all black, which means inside. Less than black, which means that greater than has to be yep. Okay. So there's those two. Now for Y. So px is greater than that and less than p2.x. So in theory, okay, all right, let's just do this. P0.x. It's greater than, or if it's greater than, it should be not it's y. Y is black, or greater than is black. P, which is what I would expect. Less than should be yes. Okay. So check looks good. Want to is greater than, less than, p2.y. So we expect this to be black. Oh, no, green? Green. Oh. Interesting. So less than green. How about the greater than? It kind of has to be black then, doesn't it? There, black. So. That means my fragment position is higher than both of these. Which means something. Maybe it means these values are negative.
I get
But we can test this. One last test, then we'll resume the grind on Monday. That's fair. Working with the logic. Contains equals true. So if we're bounded in the X thing, so it might be that my Y values are coming in wrong. If that's the case, we have to figure out what those values are. But characters outside the bounds are indeed green. So those would be truncated. Just the vertical, we just have to fix the vertical. Yes. I think that's it. I'm gonna have to call that good. Oh, all right. Thanks everyone for dropping in. I know it's been a bit of a slog day learning my OpenGL and doing all the world transforms the hard way. So we'll get this whipped on Monday. Tomorrow's Compiler's Day. Until then, take care. Bye bye.